Hi, everybody. Happy Wednesday. Don't get to talk to you very much on Wednesday, but here we are because it's President's Day. So this will be wrapping up Chapter 1. I'm going to go from here to the end of the Chapter 1 PowerPoint. That'll conclude Chapter 1. We're not going to do the test yet. We're not going to have homework this week. This is kind of your homework. This is your Thursday assignment. It's just going to be watching this video. Um, so next week we will talk about your test. It's not due next week. We're just going to talk about it next week. It'll be due the week after that. So there's a lot of information to cover today, but it's kind of simple information. And since this is a video and you can go back and rewatch it, I'm going to kind of move a little bit fast. So if there's anything you have questions on, please let me know. So we're going to start here talking about the integers. We've talked about different sets of numbers so far. We've talked about the whole numbers. We've talked about the natural numbers. Now we're going to talk more about the integers. So sets of integers are just your negative numbers along with your positive numbers. So for things like counting a number below zero or checking your bank balance if it's been overdrawn, those are all times when you're going to use negative numbers. So the first thing we'll do is define the set of integers. Remember, we got to talk about what all of our integers are. So for something like the temperature of 2 degrees above zero or the 2 degrees below zero, or a bank balance of $50 or overdrawn of $50, those are positive and negative numbers. So positive numbers are things above zero, negative numbers are things that are below zero. Things like -2, -50, -600. Those are all negative numbers. They have a little minus in front of them. So if we have both the positive numbers and the negative numbers, we call that set the signed numbers or the integers. So the set of integers can be defined as this dot 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 -5, -4, -3 all the way up to 0, then 1, 2, 3, 4, 5 dot dot dot. Your integers are just your whole numbers and the negative versions of themselves. So you're their counting numbers plus the negatives. If we were to graph them, we're going to graph them the same way we graph every number. If you want to graph a positive number, you move to the right. If you want to graph a negative number, you're going to move to the left. And to graph them, you just find the number on the number line and put it in. Some common number lines that you'll run into that use integers are things like timelines and things like thermometers, that like an old school scale thermometer. This is kind of an example here of graphing a couple of integers. So if we're graphing -3, 2, -1, and 4, for -3, we're going to start at 0 and move 3 dots to the left. That's where -3 is. To graph -1, you're going to start at 0, move 1 to the left. To graph 2, you start at 0, you move 2 to the right. And to graph 4, you start at 0, and you move 4 locations to the right. And that's all there is to graphing integers. So the next thing we'll talk about is adding integers. And so we're going to have a couple of different operations here. We're going to talk about using the different operations when it comes to integers, because it's going to act a little bit differently than just standard adding and subtracting. So if we're adding two integers that have the same sign, we're just going to add them up like normal. Okay, we're just going to add them up like we normally would, and then we give them the sign that they had at the end. So to add two positive integers, add them like you normally would, and then your final answer is just going to be positive. To add two negative integers, add just the numbers and then make them negative at the end. For example, something like -3 plus -5. These two have matching signs. -3 and -5 have matching signs. So add them like you normally would, 3 plus 5. That'll give you 8. And because they were negative at the beginning, your answer is going to be -8. Okay, we can see that with the next problem too. If we have -26 plus -65, since they both have a negative sign, treat it like normal addition. Just do 26 plus 65. When you do 26 plus 65, you'll get 91. And since both of your numbers were negative to begin with, your answer is -91. You'll do the same thing for this last problem here. Now, if you have two integers that have different signs, so something like 4 plus -3, If you have two numbers that have different signs when you're adding them, I want you to subtract the two numbers and give your answer the sign of the larger number. So for example, something like 5 plus negative 7. If I see 5 plus negative 7, I see that I'm doing addition, and I have two different signs here. This 5 is positive, this 7 is negative. So because they're different, I'm going to subtract them and then give it the sign of the larger number. So if I want to subtract these, I'm going to take the bigger number, which is 7, subtract off 5, so I do 7 minus 5, which gives me 2. Now I look back at the original problem, and the original problem here has a negative in front of that 7. So that means our answer will be negative. So for adding integers that have different signs, subtract them and give it the sign of the bigger number. Let's look at a problem like this. Let's do a couple of different operations within an expression. So for this one, we have negative 3 plus 5 plus negative 12 plus 3. Since we don't have any parentheses, we don't have any multiplication division, we don't have any exponents, we're just going to do our addition from left to right. So to start, we're going to work left to right. The first thing we're going to do is a negative 3 plus 5. And you see negative 3 plus 5 have two different signs. And since the signs don't match up, let's do the subtraction. We'll do 5 minus 3, which gives us 2. And since 5 is the bigger number and it was positive, our answer is positive 2. Now I rewrite the entire problem next. So I just grab everything else that I didn't use yet and tack it on at the end. So I'm going to grab this plus negative 12 plus 2. Now I do my second piece. I do 2 plus negative 12. I see this. The signs do not match up, so I'm going to subtract and give my answer the larger number's sign. So I have 2 and negative 12. They have different signs, so I will do 12 minus 2, which gives me 10. Now because 12 had a negative sign to begin with, our answer here is negative 10. Last but not least, we'll do negative 10 plus 2. I see that they have different signs. Negative 10 and positive 2 have different signs, so I'll subtract them. 10 minus 2, that'll give me 8. And because 10 has the bigger number and it has a negative sign, our answer is negative 8. For subtraction, we're not actually going to do any subtraction. Subtraction is kind of an illusion. Okay, we're never going to do subtraction. Instead of doing subtraction, we're going to change our minus signs to a plus sign, and we're going to write the opposite of a number. So for example, this number here, we have a is negative 6 minus 4. I'm going to rewrite negative 6 minus 4 as negative 6 plus negative 4. All I've done is rewrite the problem from negative 6 minus 4 to negative 6 plus negative 4. And you will get the same answer both ways, and you could do your rules for addition here instead of learning new rules. So let's see an example of this. This example here is negative 1 minus negative 2 minus 10. So the first step here will change all of our minus signs to adding the opposite. So for this problem, I have a negative 1 minus negative 2. So because I'm doing minus negative 2, I'm going to rewrite that as plus 2. If you were a big fan of English class here, this is like a double negative, meaning a positive. So instead of writing minus negative 2, I'm going to rewrite that as plus 2. Then over here, instead of doing minus 10, I'm going to change that to plus negative 10. And now I could do the problem like before. Negative 1 plus 2 is 1. 1 plus negative 10 will give me negative 9. Okay. let's talk about multiplication. So I think multiplication and division are actually significantly easier than adding and subtracting. Sorry. So for multiplication, the only thing that changes from the stuff we've already learned is if we have different signs. So if we multiply two numbers together that have different signs, your answer is negative. It does not matter what the signs are. It does not matter which one is positive and which one is negative. All that matters is if they do not match, your answer will be negative. So for something like 4 times negative 3, 4 is positive, negative 3 is negative. So because they do not match, when we multiply them together, our answer will be negative. So for all of these examples, 7 times negative 5, negative 93 times 16, 20 times negative 8, 34 times 1000. The only thing I care about here is saying that these signs do not match, and because they do not match, our answer is negative. If the signs don't match, the answer is negative. Now, inversely, if the signs do match, your answer will always be positive. So for 4 times 3, they're both positive numbers. Because they're both positive numbers, your answer is positive. Okay. That is also true multiplying two negative numbers. So something like negative 4 times negative 3, you'll see that they both match up. Negative 4 times negative 3. They both are negative numbers, and so your answer is positive. If the signs match, your answer is positive. If they do not match, your answer is negative. Okay? This is your summary. If they have the same sign, your answer is positive. If they have different signs, your answer is negative. Now, for a problem like these, where we have extended multiplication, we've already proven that we can do extended multiplication, so I'm just going to talk about the positives and negatives here. For this problem, we have 6 times negative 2 times 7. I do not care what 6 times 2 times 7 is right now. I know you can do that. We've already done that. I just want to see if my answer is positive or if it's negative. So, for 6 times negative 2 times 7, I'm going to start with 6 times negative 2. For 6 times negative 2, the signs do not match. So 6 times negative 2 will give us a negative number. Now we take that negative number and multiply it times negative 7, and you'll have a negative number times another negative number, which means our answer should be positive. For B, we'll run into a similar situation. We have negative 9 times 8. That's a negative number times a positive number, so that will result in a negative number. Now we take that negative number, multiply it times negative 1, and you'll have two negatives times each other, so you will end up with a positive number. This applies to exponents as well. For exponents, we actually get a little bit of a shortcut. If I have something like negative 2 to the 4th power, I can rewrite that as negative 2 times negative 2 times negative 2 times negative 2. Because they're in parentheses. Because this problem is in parentheses, I can rewrite it the way I did. I can rewrite it as negative 2 times negative 2 times negative 2 times negative 2. So because of that, if we follow our rule and do our multiplication, we'll have a negative times a negative times a negative times a negative, which means our answer will be positive. So because of this, we can see a rule. In this second problem, we would have like negative 5 to the 3rd power. We would have negative 5 times negative 5 times negative 5. And in this case, we would end up with a negative answer. So that means our rule for exponents is if a negative number is raised to an even power, the answer is positive. But if you have a negative number raised to an odd power, the answer is negative. And if you forget that rule, just write out your explanation, write out your multiplication problem, write it out long form, and you'll be able to just do it like you would normal. Now, the nice thing that we have here for division is that it's going to follow the same integer rules. So just like for multiplication, if you're dividing two numbers that have the same sign, you get a positive number. If you divide two numbers with different signs, you get a negative answer. So if we're dividing two numbers that have like signs, your answer is positive. If you're dividing two numbers that have opposite signs, the answer is negative. Let's see what these answers would be. We have a negative divided by a positive, which means our answer will be negative because the signs don't match. Second one, we have a positive number divided by a negative number, which would give us a negative number because our signs did not match. The same thing will be true with C and D. The signs do not match, which means the answers will be negative in all of them. Okay. So that is the end of chapter 1. If you have any questions about chapter 1 before I talk to you next time, please let me know. We're going to start chapter 2 next time, but your test is not due next time. We'll talk about the test in person. I want to sit down with you guys and kind of show you where to find it and how I expect it to be turned in. So don't worry about the test. Don't worry about any homework for this week. Your homework is just to watch this video and work on your workbook for all of section 1. You could do everything in section 1 now. So you should just be working on that, looking over your information, and getting ready for next time. So if you have any questions, please let me know.